A fully loaded jet weighs hundreds of tons. It has no business leaving the ground. And the explanation you were taught in school for how it does is mostly wrong. Not simplified. Wrong. The air does not behave the way that diagram claimed. And once you see what's really happening, flight stops looking like magic and starts looking almost impossible. So here's the real question. What actually holds a plane up? Not the engines. They push it forward, not up. Something about the wing is fighting gravity every second of the flight. And the popular answer hides what that something really is. By the end of this, you'll know exactly why the classic explanation fails, what genuinely keeps the wing in the air, and the single moment when all of it can vanish in seconds. And here's what makes it worth understanding. Millions of people trust this with their lives every single day. Yet almost none of them could explain it correctly. The thing keeping you in your seat at 35,000 feet is one of the most misunderstood ideas in everyday science. Let's start with the story you were probably told. A wing is curved on top and flatter on the bottom. Air splits at the front edge. The part going over the top has farther to travel, so it has to speed up to keep up. Faster air means lower pressure, and that lower pressure on top sucks the wing upward. It sounds clean. It uses real physics. Faster air really does have lower pressure. That part is true, and it has a name, Bernoulli's principle. This is the explanation in countless classrooms, and it has one fatal assumption buried inside it. Here's where it quietly breaks. The story assumes the two air particles must meet again at the back of the wing, as if they made a promise to reunite. But there is no law of physics that says they have to, and when you actually measure it, they don't. In wind tunnels, the air over the top doesn't just go a little faster. It races ahead and reaches the back of the wing long before the air underneath. It never waits for its partner. So the whole equal travel time idea the explanation depends on simply isn't real. So why is a broken explanation still in textbooks everywhere? Because it's easy to draw. It gives a tidy picture and a famous principle in one neat sentence. It's not a lie invented to fool anyone. It's a shortcut that got mistaken for the truth. And shortcuts like this hide how strange flight really is. And here's the part the school version can never explain. Planes can fly upside down. Paper airplanes fly with totally flat wings. If lift came only from a curved top being longer, none of that should be possible. So the shape can't be the whole secret. So let's throw out the cartoon and watch what the wing actually does to the air. A wing doesn't just slip through the sky. It grabs the air and throws it downward. Look at any wing in flight, and behind it you'll find a river of air pushed toward the ground. And this is where it gets interesting. Newton noticed centuries ago that every push has an equal push back. Push air down, and the air pushes you up. It's the same reason a swimmer who shoves water back glides forward. The wing shoves a massive amount of air downward, and the air shoves the entire plane up, and the amount of air involved is staggering. To hold up a heavy jet, the wings have to fling an enormous mass of air downward every single second. Tons of it, pushed toward the earth without stopping. That constant downward shove is the invisible column the entire aircraft is standing on. You felt this yourself. Stick your hand out of a moving car and tilt it up slightly. It jumps upward. Tilt it down, it dives. You just made a wing. That tilt has a name, the angle of attack. And it matters far more than the curve on top. Now the upside-down mystery solves itself. When a jet flies inverted, the pilot simply tilts the nose up relative to the air, so the wing still throws air downward. The curve is upside down and useless, but the angle does the real work. The wing keeps pushing air toward the ground, so the plane stays up. Now here's the twist that changes everything. For years, people argued about this. Is it the pressure difference? Or is it the wing pushing air down? The surprising answer is that it was never two competing theories. It's one event, seen from two sides. When the wing turns the air downward, the air over the top speeds up and its pressure drops. The low pressure and the downward push are the same thing. Think of it like a single coin. On one side, lower pressure pulling the wing up. On the other, air being driven down and pushing back. You can describe lift with either face of that coin, and you'll get the same answer. Arguing over which one is real is like arguing whether a coin is heads or tails. There's one more piece that makes it click. Air, like water, tends to cling to a smooth surface and follow its curve. Hold the back of a spoon to a running tap and watch the water bend toward it. A wing does the same to the air, steering that whole stream downward, which is exactly what creates the lift. But this is also where flight gets dangerous. All of it depends on the air staying glued to the wing. Tilt the wing too steeply, chasing more lift, and the air can't follow the curve anymore. It tears away from the surface and breaks into chaos. The moment that happens, lift collapses almost instantly. It's called a stall, and it doesn't matter how fast the engines roar. Without smooth air bending over the wing, there is nothing holding the plane up. This is the hidden edge every pilot is trained to respect. This is why wings change shape during takeoff and landing. Those panels sliding out of the wing are reshaping it to keep the air attached at slow speeds, right when the plane is most vulnerable. Every flight you've ever taken was a careful balance between turning air down hard enough to stay up and not so hard that the air gives up. Next time you fly and feel a small drop, that's the air and the wing renegotiating their deal. The plane isn't sitting on something solid. It's riding on a stream of air it has to keep bending downward, moment after moment, mile after mile. Stop bending it, and the sky stops holding you. So here's the real answer to what holds a plane up. Not a magic curve, not air politely rejoining at the back. A wing flies by violently throwing air toward the ground, and the air throwing the plane back toward the sky. The faster air and the lower pressure on top are just the fingerprints of that same downward push. Take away the downward push, and the fancy curve lifts nothing at all. Flight was never magic, and it was never quite as simple as the diagram promised. A plane stays up by constantly bargaining with the air, pushing it down just hard enough, every single second, to keep falling and never landing. If you want the next video to break down another hidden system running quietly behind your everyday life, subscribe.